Okay, so we've worked a lot with rational expressions and determining limits. So one of the things we haven't dealt with is what happens as they go to infinity. We may be asked this several times: if the limit as x approaches infinity or negative infinity of f of x over g of x. So what happens here, not surprisingly, is much like what we already discovered in trying to do asymptotes in the previous video. That if we think about the functions, there's basically three different cases that can happen. Number one is that the power on f of x is bigger than g of x. So again, if f of x is growing larger at a faster rate than g of x, then that limit is just going to go to infinity or negative infinity. There's not really a limit, it just keeps going on forever and ever. The second thing that can happen is if f of x has a smaller power than g of x. If f of x has a smaller power, g of x grows bigger. So what we see is that limit goes to 0. And then the third way this can happen is what if they have the same power at their highest level, then it turns out that the limit is the ratio of the coefficients. And again, this is exactly what we ran into when we were trying to find horizontal asymptotes with our graphs earlier. So we should be accustomed to using this kind of information. So let's take this and try to solve a few quick problems here using those limit rules. In fact, it just says more limit rules. By what I really mean here are the infinite rules. So in this case, limit as it goes to infinity. This one is raised to the first power. That one's raised to the first power. So they work at the same rate. We can just cancel those out, and we get that it is 4/3. When it's the same, it's the ratio of the coefficients. If we look at this one, I'll try to zoom in case you can't see all the numbers. Now maybe getting a little blurry. This one is raised. This is 6x to the third power is the highest value there. This is 8x to the fourth power, so bigger one in the denominator. So turns out, since this is bigger than every part here, it's going to swallow up all of them and will end up going to 0. One of the key points that allows us to work with that is remembering that because of the addition and subtraction laws and the quotient laws, that we could actually break this apart. The reason we only have to look at the biggest part is because we could break it down and look at each one individually. So if we looked at 6x plus 3 over this, then it's going to get swallowed up. And certainly anything smaller than that is also going to get swallowed up. So that's why we only have to look at the beginning part. All right, part C is the other scenario, in which case 5x to the fourth is the biggest power here. 7x cubed is the biggest power there. So as we go to infinity, this is going to get bigger by the fourth power. That's the third power. So actually this ends up knocking out all those other expressions. This is the dominating power. So this one's going to actually go to infinity. And we can double check whether it's positive or negative infinity by kind of looking at what the signs would be. As we get a bigger positive number here, that number's going to be positive. This down here is still going to be positive, just not as quickly. So those are our three rules and how we use them, each different one. And so hopefully that will give you a good way to work with limits going forward.